We've talked about trying to see our beliefs as shades of grey, rather than black or white where we're 100% certain about the future. But how do we change these beliefs when new information comes in? If we're 50% sure of something and new evidence comes in, how much should we change our minds? Now here, we can go too far in either direction. At one end, we can flip and flop our beliefs with every new argument. We might end up being blown around like a plastic bag in the breeze. Plastic bags are famous for being easy to persuade. At the other end, we can stubbornly resist new information, even when the evidence should be convincing. Let's work through a hard example to get an intuition for how to do this well. Today's fun question: how likely is it that artificial intelligence takes over and kills everyone? This seems like an impossible thing to put numbers on. We don't have a track record of AI catastrophes we can look at to see how common they are in the past. But if the odds are 1 in 20, we should act very differently than if the odds are 1 in 20 million. This means the number matters. One way of getting these numbers might be to ask experts in AI. In 2016, researchers at Oxford, Yale, and a nonprofit called AI Impacts conducted a survey of top machine learning researchers. Now, no survey is perfect. You can't ask everybody. Sometimes the kinds of people who want to answer surveys about dangerous AI are the very ones who think it's dangerous. But they got about 350 presenters from 2 of the top machine learning conferences, so it's a decent sample. They asked the presenters, assume we can make machines that can accomplish every task better than humans. How positive or negative do you expect the overall impact of this to be on humanity in the long run? This is what they found. Experts felt AI could be really good, freeing us of drudgery. This is why so many companies are trying to build these AI. But experts also felt there was about a 5% of AI being disastrous at the scale of human extinction. It might seem easy to dismiss small probabilities like this. After all, experts felt we were going to be okay most of the time. But you might be concerned about even small probabilities of very bad outcomes. Would you get on a plane with those odds if the pilot and the team of engineers told you there was a 5% chance of it crashing and killing everybody? The experts also said this plane is probably taking off in my lifetime, a 50-50 chance by about 2060. This isn't a lot of time to see if the in-flight movies are any good. So, if these numbers are right, it could be important for all of us. Since that survey in 2016, a lot has happened in artificial intelligence. When I look at the AI news, should I be more or less worried? Let's look at some data points. AI has helped us to control nuclear fusion reactors, which gets us closer to a new green source of energy. This could massively help us tackle climate change. In medicine, AI models have surpassed our abilities in predicting how protein structures fold, which has given us new insights into biology. These seem great for humanity, but AI has led to some bad things too. As more people started using chatbots, there were case studies of AI giving people instructions for making napalm. At least one person's death has been partially attributed to their interactions with a chatbot. It gave him very specific instructions for his suicide, one of which he followed. But these are just case studies. Should they change our mind? Well, what about this one? In 2022, researchers had built an AI model to discover safe new drugs. Then they wanted to see if they could find dangerous chemicals instead. Within 6 hours, the AI model generated 40,000 possible chemical weapons. It found some of the most deadly chemical weapons we already know about, and some new ones that appear to be even more deadly. But all of these are just case studies. With new evidence like this, how much should we update our probabilities? Are a few case studies weak, neutral, or strong evidence that things will turn out badly in the end? We need to figure out the right way to change our mind in response to new evidence like this. We can learn to do this well using ideas from Bayes' rule. Let's borrow an example from Julia Galef, author of the book Scout Mindset. Imagine we're walking across my campus and meet a guy named Tom. He's shy, not really making eye contact and mumbling a bit. If you had to guess, do you think Tom's from the business school or is he a maths PhD candidate? Lots of people say maths PhD. It kind of fits the stereotype. If you take the average business student and the average maths PhD, the business student is less shy and more extroverted. But that wasn't the question. There's an important piece of information we need to consider. What's the base rate of studying business versus a maths PhD? My uni has over 5,000 students studying business every year. In contrast, there's less than 100 maths PhD candidates. If picking at random, the odds of me bumping into a business student is about 50 times the odds of a maths PhD. It's 50 to 1. So let's draw this out. Even if only 10% of business students came across as shy, and over 80% of maths PhDs came across as shy, the breakdown would look like this. You can see there are still more shy business students than there are shy maths PhDs, just because there are so many business students to begin with. If you want to pretend to have a maths PhD, you can multiply the odds. The odds of a random student being from business instead of the maths PhD program is 50 to 1. The odds of being shy from the maths PhD program might be 8 times higher than the business school, so call it 1 to 8. Multiply these odds together and you get about 6 to 1. It's still 6 times more likely Tom's from the business school than the maths PhD program. Multiplying the odds in this way uses what's called Bayes' rule. You want to know the odds of something given your new information. You start with your reference class. Basically, what were the odds of that thing happening anyway? In Bayesian probability, we call this your prior, your belief before you got the new information. What were the odds of Tom being from the business school knowing nothing about him? That's your prior. You multiply that prior by what's called the likelihood ratio, the probability of Tom being shy if he was a business student divided by the probability of Tom being shy if he were a maths PhD candidate. This gives you your posterior, your belief now you've got the new evidence. Now, you don't need to use this jargon or draw these diagrams or ever really do the maths. I almost never do. But Bayes' rule gives us some thinking tools that helps us to become more accurate, no matter what we're trying to figure out. First, you can see your priors matter a lot. Without the priors, Tom looks to be 8 times more likely to be a maths PhD candidate. With the priors, he's 6 times more likely to be a business student. This is why base rates mattered so much when we were talking about forecasting. When we're making judgments, if we neglect the base rate, we're going to be a long way off. The second tool is to consider the odds of the thing happening both if you're right and if you're wrong. Sure, Tom's more likely to be shy if he's from the maths program, but there are plenty of shy business students too. Coming back to AI, in a world where things go badly, it's likely that one person would suicide after an interaction with AI. But this also seems pretty likely in a world where things go well. There are lots of people chatting to lots of AI models. Tragedies are pretty likely to happen by chance. On the other hand, AI can learn to create chemical weapons seems more likely in a world where AI goes badly. In a world where AI is extremely good for humanity, we kind of hope that AI wouldn't be designing new weapons. They'd be too busy building carbon neutral chocolate factories. But the main lesson here is to not just look at the world where you're right and where everyone else is wrong, otherwise known as Twitter. Don't just look at the odds of maths PhD students being shy. Instead, compare the world where you're right against the world where you're wrong. What would I expect to see, and how is it different from what I currently see? The third tool is to slowly update your beliefs in response to evidence. One reason we use the hierarchy of evidence is that better data should update your beliefs more. If you have a smart, thoughtful friend who becomes healthier on a plant-based diet, it doesn't mean it will work for you, but you might be 1% more likely to think it could help. A cohort of 50 people would provide stronger evidence, a randomized trial even stronger, and a meta-analysis of randomized trials should update your beliefs a whole lot. That's because a significant effect from 50 studies is much more likely in a world where the thing actually works than in a world where it doesn't. Still, no meta-analysis is perfect, so you might not want to update to 100% certain. I think you should always want to be open to new evidence. But notice how each bit of evidence could update your beliefs a little bit rather than flipping you from carnivore to vegan with one case study. When I first started thinking about risks from artificial general intelligence, I lumped it in the sci-fi bucket. I didn't think we could make computers as smart as humans. I was almost certain the chance was 0. To quote Andrew Ng, an AI researcher, I thought big risks of AI were like worrying about overpopulation on Mars. Slowly, I've seen AI do more and more impressive things.
What is narcolepsy?
You are right, and with that, you move to 36,681.
AI models have beat the world's best players at games like chess and Go and StarCraft. I slightly increased my odds that they could solve complex problems, but I doubted their real-world intelligence. A few years later, I started using GPT-3, a precursor to ChatGPT. I could feed it a few of my video scripts and it could write like me on any new topic. So I increased my odds a little more that AI could understand the world. As more and more powerful AI models have come out, they've shown better and better performance at a wide range of tasks. It now looks like they can pass the bar exam to become a lawyer and pass entrance exams for most graduate programs. This doesn't leave me certain that we can make computers as smart as humans, but I've slowly been updating in response to new evidence. These things seem more likely to have happened in worlds where artificial general intelligence is possible compared to when it's not. So each data point has increased my odds that it might happen in my lifetime. As far as the risks from AI goes, we don't actually want to find the truth about whether or not we go extinct. Still, the probability matters. If it's 1 in 20 million, then maybe the fusion reactors and the biotechnology are worth the risk. If it's 1 in 20, maybe we should pause AI or slow down a little until we can be sure we can make it safely. The same survey researchers went back and asked AI experts about their risk perceptions to see if anything's changed since 2016. Experts think artificial general intelligence is coming a little quicker now than they did before, and they're still pretty concerned about the really bad outcomes. The median probability of extinction from AI is still about 5%, but with more and more real examples of AI going awry, the amount of effort they think we should put into safety research has increased substantially over time. Now, sure, these experts are not mathematically updating their priors using Bayes' rule, but they show how we can incrementally update our beliefs in response to evidence. We can make sensible probabilities for things that might happen, even if we never want them to eventuate or they've never happened in the past. Our predictions will never be perfectly right, but if we find good priors, ask where we might be wrong and update incrementally, we can hope to get less and less wrong.